which makes my little pointer flash. All right, today we are going to practice what we were learning on Friday, which is sex-linked traits. And on Friday, I don't think I told you about how these were discovered, did I? No, I didn't think I did. It's very interesting the way now remember, these are variations in Mendel's theories, because Mendel came up with what three concepts? Dominant recessive, segregation, and unit characteristics. Excellent. So he didn't discover everything, but he did discover the foundational principles, the concepts. So I don't remember what year it was, but Dr. Morgan and his associates were studying genetics using a fruit fly, or using fruit flies. And that's very common now. Mendel, of course, used what? Pea plants. And that took a long time because they only reproduce once a year. Fruit flies reproduce very quickly. So you can study many generations in 1 year. So they were doing their, studies, and all of a sudden they found a white-eyed fruit fly. Now normally they're red. So I thought, this is odd. Let's take this male that is white-eyed and let's cross it with one of the females. So they did that. They got all red. So that told him, what about red eyes? That it's a dominant trait. But then he said, well, let's cross 2 of those offspring. So they did two of those offspring, and then the next generation. And once in a while, they would get a white-eyed fruit fly. And most always it would be male. Very rarely would they ever get a female that had white eyes. So it was through this discovery that they reasoned that there must be some genes that are found only on the X sex chromosome, which is what a sex-linked trait is. The genes are found only on the X sex chromosome. Does that mean the Y chromosome does not have any genes on it? No. The Y does have some genes on it. The X has some extra genes on it. And these are called sex-linked traits. Now, for females, what are our sex chromosomes? An X and an X. For males, what are your sex chromosomes? X and a Y. Now, for the males, where did you get your X? Mom. And where did you get your Y? Dad. Girls, we've got one X from mom, one X from dad. So mom only has X chromosomes to give to her children. All of us that are daughters, that means our dad gave us an X chromosome. All of you that are sons, that means your dad gave you a Y chromosome. And that produced the daughters and sons. With sex-linked traits, and you might want your notes out from Friday because that was the first time we went over this. How do we start a sex-linked trait problem? Because we're going to work on that, not that handout, but the one from Friday, 7E-1. Okay, who can tell me how do we start a sex-linked trait problem? Jordan? That's actually step 2. So the T-chart is step 2. Yes, so write down the set of contrasting traits. Okay, so write down the set of contrasting traits and assign a capital letter to the dominant trait and a lowercase letter to the recessive trait, because these are dominant recessive. Now read in your notes, what is always dominant in a sex-linked trait problem? Normal. So that's the first thing you should write down. Normal gets the capital letter. What letter did I say use? Look on your handout. H. So what trait are we dealing with on this worksheet? Hemophilia. So what's the recessive gene? Hemophilia. And that gets the lower H. So that's the first thing you do is write down your set of contrasting traits. Normal is dominant, so it gets the capital letter, whatever trait you're dealing with. Let's go over what are some human characteristics that are sex-linked traits. Hemophilia, red-green color blindness, muscle, muscular dystrophy, and male pattern baldness. Very good. And those you have to have memorized and know that. Remember, the quiz is on Wednesday. All right, now, T-chart. And this is your blank T-chart. So how does it differ from a dominant recessive problem? You have 5 possible genotypes and 5 possible phenotypes. And how else does it differ? There's 3 for the females and 2 for the males. You have the sex chromosomes. You didn't normally put that, right? So here you have to put the sex chromosomes. So we have 3 possibilities for girls and 2 possibilities for guys. How come? Well, let's think about it. How many X chromosomes does a female have? 2. 1 from mom, 1 from dad. How many X chromosomes do the guys have? 1. So how many genes for a sex-linked trait does a guy have? I didn't hear what was that? 1. How many X's do they have? 1. So how many genes do they have? 1. And how many genes do the girls have? 2. That's why there's 3 possibilities for girls, because they have 2 genes for these traits, not just 1. Okay, now let's do our genetic possibilities. One daughter could get a normal gene from each parent. How do we put the genes on the X chromosome? As what? Like an exponent. So do that. So from one parent, she gets a normal gene. From the other parent, she gets a normal gene. On the handout from Friday, 7E-1. That's one. Look at what the other people are writing on. So what is the phenotype? You must include what in the phenotype? The sex, because these are sex-linked traits. So that's a normal female. Now, another daughter, they could have gotten a normal gene from one parent and the hemophiliac gene from another parent. So that's what we call hybrids. And in sex-linked traits, we have a special term for a hybrid, carrier. So that's the phenotype. How come I didn't put female carrier? Only females can be carriers, so it is understood to be a female. There's no such thing as a male carrier, because a carrier is a hybrid. And to be hybrid, you have to have 2 genes. The males have 1 gene. And where did they get that 1 gene? From mom. Yes, Allie? Which one? I mean, no, that's a fact, because it's impossible. They don't have 2 genes. Okay, so for sex-linked traits, there's no such thing as a male carrier. A good thought. Now, the other possibility, and think about how slim the chances are that one parent would give the hemophiliac gene to their daughter, and also the other parent. So from mom and dad, they get the hemophiliac gene, which means dad is what? A hemophiliac. And what is the phenotype for that person? Yeah, but you got to put the sex. So a female hemophiliac. And that's our possibilities for the daughters. Now for sons, you only have two. Whatever you got from mom, that's what you are. So if mom gave you a normal gene, you are normal male. If mom gives you a hemophiliac gene, you're a male hemophiliac. So that's our step 1 and 2. Next we do the parents when they tell us to cross. But look at our problem. It doesn't say anything about showing a cross yet, does it?
Is there such thing as a male carrier? Then why do it have to be
Guess what your answer is? No. We'll go over it. We're going to go over it. Okay, 1 through 6. Do I need to work a cross to answer those? No, you just work step 2. That's all you need. So everybody do 1 through 6, and then we're going to check them. Remember, if some of you are faster than others, you can work on your homework while you're waiting. Tucker?
Can apply carry anything at all?
It has other genes, but not sex-linked trait genes. So in these problems, it doesn't have anything. Anybody still working on 1 through 6? Okay. All right, let's look at our answers, see how you did. A female who carries the gene for hemophilia would be right there. 2 X's, a capital H on one, a lowercase h on the other. A male who carries, which one of these is a male carrier? None. It's impossible. So you shouldn't. He doesn't carry it. A carrier expresses normal. He doesn't express normal. He has hemophilia. He is normal. So it's impossible. No such thing. And that's what you write. You don't put, just an X and a Y there. You put the word impossible or the words no such thing or not possible. All right, a normal female is the first one we did. Purebred dominant. So you have 2 X's and a capital H on each one. A normal male is the second to the last, and that is a capital H on the X, nothing on the Y. A hemophiliac female is 2 X's and a little H on each one. And then last but not least, number 6, a hemophiliac male. That's an X with a capital, X with a lowercase h and the Y with nothing. So we did those. All right, now let's work on 7 through 12. Show a cross between a female carrier of hemophilia with a male who has hemophilia. And somebody come to the board to put the cross up here. Okay, Maxwell. Use that one right there. Make sure you write it more as an exponent. So up, yeah, that's better. So the female's a carrier. The guy is a hemophiliac. Female goes where? On top. Males go on left side. Good. Okay, when you do the cross, first possibility is what? Carrier. Second possibility? What sex? Female hemophiliac. Third possibility? Normal male. And fourth possibility? A male hemophiliac. Okay, let's answer our yes and no questions. 7. Will any of their children have hemophilia? Yes. Will any of their boys have hemophilia? Yes. Will any of their girls have hemophilia? Yes. Will any of their children be carriers? Yes. Will any of the girls be normal? No. Will any of their boys be normal? Yes. And those yeses means there's just a possibility. Obviously, if they don't have 4 children, they're not going to have all 4 of these possibilities. Even if they have 4 children, they might not have all 4 of these show up. It just means every single time they have a child, there's a 50% chance that they'll have hemophilia, a 25% chance that there would be a carrier, 25% chance that there would be a normal male, and so on. Okay, any questions on 7 through 12? Now, I want you to highlight something before we do 13 through 23. Highlight, underline, or something. Look at the question for 13 through 18. It says, of their offspring. So what's the genetic possibilities of the offspring? How many possibilities? 4. You think, well, that hasn't changed. We've always been doing out of 4. You're right. There's out of 4. But look at question 19 to 23. 19 to 21 says, of the females. So how many genetic possibilities are there for the females? 2. So your denominator on 19 through 21 becomes 2, not 4. That's what's different about these than the other time of dominant and recessive. And then of the males, how many genetic possibilities of males? 2. So our denominator becomes 2. All right, so let's do the cross then. Show a cross between a hemophiliac male and a normal female, and then answer the rest of those questions. And I'll have somebody come up and do the cross. Okay, Nicole? Good. Excellent. No. Look at your directions on 13 through 18 of their offspring. So that means out of 4. Offsprings out of 4 out of one sex is over 2. Anybody not done with 23? Question 23? Okay. Remember, those of you that are ahead of the others, work on your homework. You can get it done. Okay, anybody not done with question number 23? Okay. All right, let's go over the answers. The cross is here between normal female and a hemophiliac. What's going to be true of every daughter that they have? Carrier. What's going to be true of every son that they have? Normal. So it says, how many are female carriers? The answer? 2/4, 1/2, or 50%. Very good. 14. Male carriers. Impossible. If you put 0 out of 4, that would be wrong because you're telling me it is possible, there just weren't any. So it's the word impossible. Don't put none because that would be the same as 0. It'd be impossible. Not possible. No such thing. Okay, next page, 15. Normal females. 0 out of 4 or 0%. 16. Normal males, 2/4, 1/2, or 50%. 17, hemophiliac females, 0 out of 4 or 0%. 18, hemophiliac males, 0 out of 4 or 0%. Now it changes. 19 through 23, it's going to be over 2. So of the females, how many normal? 0 out of 2 or 0%. Carriers? 2 out of 2 or 100%. Hemophiliacs, 0 out of 2 or 0%. Then 22 and 23 of the males, how many are normal? 2 out of 2 or 100%. And how many hemophiliacs? 0 out of 2 or 0%. Excellent. Now 24, show a cross between a female hemophiliac and a normal male. A female hemophiliac and a normal male. Now, Allie, you want to do it on the board? Excellent. So look at their children. Yes. If you put 1, you would have 5 numbers, and you would just go in this order. Okay? Which you could put it if you wanted to. But you don't have to. Because now we know how to use it. We don't even have to write it down. Okay, so now look at their kids. Is it possible for them to have a normal child? No. All the daughters are going to be what? Carriers, and all the sons are going to be hemophiliacs. All right, we got one more cross, 25, show a female carrier and a normal male. A female carrier and a normal male. Excellent. Great job. So here, look at the daughters. We've got 2 possibilities for the daughters. Every daughter has a 50-50 chance of being what? Normal or a carrier. Every son has a 50-50 chance of being normal or a hemophiliac. So that's their possibilities. All right, the rest of the time you can finish your homework sheet. If you finish your homework sheet, which is not, you can work on exam review if you need to, or you can work on your biomes project. All the computers are going, you can work on that. And you can work together. Let me shut my recording off.